The AI world was recently set ablaze by a rather provocative tweet. "Game over for LLMs?" it boldly declared. This sparked intense debate and speculation. Had something revolutionary happened? Was this the end of the road for large language models as we knew them? The tweet referred to a groundbreaking research paper. This paper delved into the very core of how we understand artificial intelligence. It questioned the effectiveness of a popular technique called reinforcement learning. RL is often lauded as a powerful tool to enhance the reasoning capabilities of AI. But was this praise truly deserved? The research paper's findings sent shockwaves through the AI community. It suggested that RL, while seemingly effective, might not be the game changer many believed it to be. This ignited a firestorm of discussion. Researchers, developers, and enthusiasts alike were eager to dissect the paper's claims. The future of AI seemed to hang in the balance. At the heart of the research paper lies a fundamental question. Does reinforcement learning truly enhance the reasoning capabilities of AI? To answer this, the researchers conducted a series of experiments. They pitted a base language model against a model trained with reinforcement learning. The goal was to compare their performance on various reasoning tasks. The research design was both elegant and insightful. It focused on a key aspect of AI, the ability to learn and adapt. The researchers wanted to understand if RL truly enabled AI to think more critically and solve problems more effectively, or was it simply a clever illusion, masking a more superficial form of learning? The research paper didn't shy away from complexity. It acknowledged the nuances of AI development. The researchers recognized that there are no easy answers. The quest to create truly intelligent machines is fraught with challenges, and understanding the true potential of techniques like RL is crucial for progress. The research paper presented a fascinating comparison between two models. One was a base language model. This model was trained on a massive dataset of text and code. The other was trained using reinforcement learning. This model had the advantage of learning through trial and error, receiving rewards for correct answers. The researchers tested both models on a variety of tasks. These tasks were designed to evaluate their reasoning and problem-solving abilities. The tasks ranged in complexity. Some required simple pattern recognition, while others demanded a deeper understanding of language and context. The results were intriguing. They painted a complex picture of the strengths and weaknesses of each approach. The RL model, as expected, showed remarkable proficiency in certain areas. It excelled at tasks where it could leverage its experience from past rewards. However, it faltered when faced with novel or unexpected challenges. The research revealed that RL models possess a unique ability to excel in specific domains. They are particularly adept at tasks with clearly defined goals and rewards. For instance, in game-playing scenarios, where the objective is to achieve a high score, RL models often outperform their base model counterparts. However, the study also highlighted areas where RL models stumble. When faced with problems that require broader reasoning or the ability to transfer knowledge to unfamiliar situations, RL models often fall short. This suggests that while RL can be powerful, it may not be the silver bullet for achieving true artificial general intelligence. These findings underscore the importance of a balanced perspective in AI research. While it's tempting to get swept up in the hype surrounding a particular technique like RL, it's crucial to maintain a critical eye. Understanding both the strengths and limitations of different approaches is essential for making informed decisions about the future of AI development. Section 5. The narrow path of RL. Exploring the limitations of reinforcement learning. The research paper's findings suggest that reinforcement learning, while a powerful tool, may lead AI down a narrow path of learning. It encourages models to optimize for specific rewards, potentially limiting their ability to develop broader reasoning skills. This raises concerns about the long-term implications of relying too heavily on reinforcement learning for AI development. Imagine a chess-playing AI trained solely with reinforcement learning. It might become incredibly proficient at winning games. But would it be able to apply its knowledge to other strategic domains, like business negotiations or political strategy? The narrow focus of reinforcement learning might hinder its ability to transfer learning to different contexts. The limitations of reinforcement learning highlight the need for exploring alternative and complementary approaches to AI development. While reinforcement learning can be a valuable tool in certain scenarios, it's essential to investigate methods that foster broader, more generalized learning. This will be crucial for creating AI systems that can truly understand and reason about the world around them. Section 6. Compressing knowledge, not expanding it. A critical look at RL's impact. One of the more provocative arguments put forth by the research paper is that reinforcement learning, in some instances, might actually be compressing knowledge rather than expanding it. The paper suggests that RL models, while seemingly improving, might be developing shortcuts to achieve high rewards without truly understanding the underlying concepts. This argument challenges the common perception of RL as a method for enhancing AI's understanding of the world. Instead, the paper suggests that RL might be leading to a form of overfitting, where models become highly specialized in a narrow domain without developing true general intelligence. This insight has sparked debate within the AI community. Some researchers argue that the compression of knowledge might be a necessary step in AI development, allowing models to process information more efficiently. Others, however, express concern that this compression might come at the cost of true understanding and generalization. Section 7. True reasoning or clever regurgitation, the ongoing debate in AI. The debate surrounding RL's impact on AI reasoning boils down to a fundamental question. Are these models truly reasoning, or are they simply regurgitating information and patterns they've learned during training? This question lies at the heart of understanding the potential and limitations of current AI systems. Distinguishing between true reasoning and sophisticated mimicry is a complex challenge. RL models can generate human-quality text, translate languages, and even write different kinds of creative content. These feats are impressive, but they don't necessarily prove that the models understand the meaning behind the words they generate. The research paper argues that while RL models can achieve impressive results, they may not be displaying true reasoning in the same way humans do. This distinction is crucial for understanding the current state of AI and for guiding future research towards developing systems that can reason, understand, and learn in a more human-like way. Section 8. The Perils of Overfitting, a cautionary tale in AI development. The research paper's findings serve as a cautionary tale about the perils of overfitting in AI development. Overfitting occurs when a model becomes too specialized in the data it's trained on, performing well on familiar examples but struggling to generalize to new, unseen data. Imagine training an image recognition AI solely on pictures of cats. It might become incredibly accurate at identifying different breeds of cats. However, it might fail to recognize a dog or a bird because it's overfit to the specific features of cats. The research suggests that RL models, while powerful, might be susceptible to overfitting, especially when trained to optimize for narrow objectives. This highlights the need for careful consideration of training data, evaluation metrics, and the potential for overfitting when developing AI systems. Section 9. A glimpse into the future efficiency versus true intelligence in AI. The research paper's findings offer valuable insights into the ongoing quest for artificial intelligence. While RL has undoubtedly propelled the field forward, the paper's findings suggest that true AI, capable of human-like reasoning and understanding, might require more than just optimizing for rewards. The pursuit of AI is often framed as a quest for efficiency. We want machines that can perform tasks faster, more accurately, and with less human intervention. But the question remains, can we achieve true intelligence simply by optimizing for efficiency? The research paper suggests that the answer might be more nuanced. While efficiency is undoubtedly important, it might not be sufficient for achieving the holy grail of artificial general intelligence. The paper's findings underscore the need for continued exploration of new training paradigms, evaluation metrics, and a deeper understanding of the nature of intelligence itself. The journey towards true AI is far from over, and the search for answers continues.